I am Prabhakar. We will be talking about instantaneous velocity of an object moving in a straight path. Consider an object moving along a straight path like what I am indicating here. Let us say it starts, the origin is O, the reference point, and its position coordinate x varies with time. Then how do we define instantaneous velocity of this object moving along a straight path? Let us look at this graph, position time graph, in a very small interval of time, that is from time t to t plus delta t of the particle moving along a straight path. Its position coordinate at time t is x, at time t plus delta t is x plus delta x. Now, to find the average velocity in the interval t and t plus delta t, what we do is you join this point P to point Q and you get this line. Now, in the interval t and t plus delta t, that is the time gap being delta t, the change in position is given by delta x in the figure, which is shown as delta x. The time interval is delta t, which is indicated. Now, this delta x is the height of this triangle and delta t is the base of this triangle. Delta x by delta t is the ratio of the height to the base of this triangle, which is found by the line p q. The value of delta x by delta t is generally called average velocity. Now, look what I am going to do is to reduce this time interval between t and t plus delta t. Consider an interval of time which is smaller than this. At that instant of time, the particle is object is at q1, q dash. Join the line p q dash and form the triangle, the right angle triangle p q1 r 1 or p q dash r dash, whatever it is. Now, delta x dash is the height of this triangle and delta t dash is the base of this triangle, and the line that is p q dash, the slope of this line is delta x dash by delta t dash, which is average velocity in that interval of time delta t dash. You reduce this time gap smaller and smaller and then ensure that you make it almost 0, then in that case the slope of this graph goes on increasing, and at point P, when you make delta t almost tending to 0, you draw a line which is called the tangent line at the point P, and the slope of this line is called the instantaneous velocity. The slope of the line at P, that is V, which is the slope of the tangent at point P, is written as limit of delta x by delta t tending to 0, is called the instantaneous velocity at point P. This is instantaneous velocity. When we say instantaneous velocity, it is limit of delta x by delta t as delta t tends to 0, which is nothing but if the slope of the tangent that is drawn at that instant of time of the x position time coordinate graph. So, V is called rate of change of displacement, because delta x is a measure of the displacement and time rate of change of displacement at a given instant of time is called the velocity at that instant. When we say instantaneous velocity, we write it as V is limit of, that is change in position coordinate, which we have called it as delta x, which is nothing but displacement per unit time when the time interval is very, very small. So, we write V is equal to limit of delta x by delta t as delta t tends to 0. In other words, in the language of mathematics, this is indicated as dx by dt. They mean the time variation of position with respect to time variation of position, that is rate of change of x with respect to dt t, which they write it as differential of x with respect to time. So, velocity is nothing but rate of change of position with respect to time. This is instantaneous velocity. Now, let us look at another position time graph, that is change of position with respect to time, that is x t graph. Now, look at this graph. The position is continually changing, the object is moving in a straight path, but the displacement, the change in position is indicated along the curve. Can you find out the instantaneous velocity at p, instantaneous velocity at q, or instantaneous velocity at r? Can you compare the instantaneous velocities? Now, look at this. How do we do? If you draw a tangent to the curve at this point, which I am indicating like this tangent has a slope which is given by delta x by delta t and very small interval of time, and this happens to be, this slope of this tangent happens to be a positive slope. If I draw a tangent to the curve at point q, the tangent line touching this curve at only one point, and this is 0 slope. Look at this point R. If I draw a tangent that almost coincides with the curve, this slope of this tangent is negative. It means at point P, the object has positive velocity, the object has 0 velocity at point Q, at point R, the object has negative velocity. When the object has positive velocity, it means whatever you have defined as positive direction, the object will be moving along that direction. When you have negative velocity, it means the object will moving against the original direction, which you have called it as positive. It means the object, in this case, in the case of an object moving in a straight line path, the object is trying to come back, is coming back or moving in the opposite direction. The velocity direction, the direction of velocity, when you say it is positive, it is along the moment. When you say the velocity is negative, it means the object is moving against the direction in which it was originally moving, or the object is trying to retrace. When you say the object is at rest instantaneously, that is at q, its instantaneous velocity is 0. The object is continually changing its position, but at some point of time its velocity could be 0, after that it could be negative, it could be positive. So, an object moving in a straight line path will consider the velocity variation with time. Look at this graph which I have presented, which shows the variation of velocity with respect to time. We will discuss about the variation of velocity with respect to time in the next session with the idea of what is meant by acceleration of an object moving in a straight line.